Hi guys, this is the last lesson in Unit 5 and it is triangle inequality theorem. And the goal is to use the triangle inequality theorem to show triangle side relationships. And the standard is congruence number 10. In this lesson, you should understand that for any triangle, the sum of the lengths of two sides is greater than the length of the third side. All right, the triangle inequality theorem says the sum of the lengths of any two sides of a triangle is greater than the third side. So if you add xy and yz, whatever those lengths are, it's going to be greater than this. If you add yz and xz, it's going to be greater than this. If you add xz and xy, it's going to be greater than this. So no matter which two you add, it's going to be bigger than that third side. All right, the first question, can the sides of a triangle have lengths 1, 2, and 3? So I'm going to take the two smallest sides, 1 and 2, add them together. 1 plus 2 is 3. Is 3 greater than 3? No. So triangles cannot have the sides lengths 1, 2, and 3. When you add the lengths of two sides, it must be greater than the third one. Always add the two smallest sides to see if it's greater than the largest side to check that theorem. Practice 1. Can the sides of a triangle have lengths 4, 4, and 9? Practice 2. Can the sides of a triangle have lengths 2.7, 6.4, and 6.8? Now you could be given two sides of a triangle like this. A triangle has two sides of length 4 and 17. What is the smallest possible whole number length for the third side? When they want the smallest one, that means we need to subtract. So I need to know some number, x plus 4 must be greater than 17. So I need to find the smallest number. So I'm going to take 17 minus 4. That gives me 13. Anytime I need the smallest one, I'm going to add 1. So that gives me 14. So the smallest possible number for that third side is going to be 14. So if you want the smallest possible number, take the biggest number minus the little one and then add 1. Subtract and then add 1. Your turn. A triangle has two side lengths of 14 and 12. What is the smallest possible whole number length for the third side? I'm given two side lengths of 11 and 12. What is the largest possible whole number? This is kind of the opposite. I need to know that 11 plus 12 is greater than what number? So I'm going to add them. 11 plus 12, which is 23. And instead of adding 1, I'm going to subtract 1, which gives me 22. So when I want to find the largest number, I'm going to add them and then subtract 1. That way, when I add 11 plus 12, it has to be 22 or less. Your turn. A triangle has two side lengths of 14 and 9. What is the largest possible whole number length for the third side? That's the final lesson. That also was pretty easy. And where are you on the scale? Don't want to stop at I don't get it, or I sort of get it, or I got this, or I'm so good I can teach this. Where are you on that scale? And that's the end of Unit 5. There's not going to be any tests, so I'll see you in Unit 6. Bye.